Namaste everyone, myself Mohit, 10th grade, studying in Purnapramati, Bengaluru. We are all familiar with the concept of temperature. Temperature is the average measure of the kinetic energy of molecules of an object. We use Kelvin, Celsius, Fahrenheit scales to measure the temperature. Did you know that we could produce electricity from temperature? Let me explain. In 19th century, a German scientist known as Thomas Johann Seebeck found out that when two dissimilar metals, he took iron and copper, were connected at two different points and those two junctions were kept in hot and cold water, along with the heat flowing towards the cold water, the electrons also flowed, thus forming electricity. This process is known as the Seebeck effect, and the combination of the two metals is known as a thermocouple. Now let's see how this works. Here we have a specific thermocouple called the J-type thermocouple. It is made up of two types of metal. One is the iron and the other is the constantan. Constantan is an alloy of copper and nickel. So here we have boiling hot water and ice cold water. So now let us check the voltage produced. So as we can see here, 0.003 volts is produced. I will explain you the theory part. Creating a temperature difference across a similar type of metal will not produce voltage because the electrons equilibrate due to the homogeneity of the medium. When we connect two different metals together, the electrons tend to move towards one of them because of the difference in the chemical composition of the two, thus producing voltage. Here we have a diagram of this thermocouple. One junction is heated while the other is cooled. Because of the heating, electrons at junction 1 gain more energy and tend to move towards the junction 2, thus producing a larger voltage than V2. Because of the net voltage, the electricity is produced. Based on this, every metal is given a Seebeck coefficient. It is a measure of the voltage produced by a material from a temperature difference across its ends. Its unit is microvolts per Kelvin. This effect can be expressed as this formula: V is equal to S into delta T, where V is equal to the voltage, delta T is equal to the temperature difference, and S is the Seebeck coefficient. The Seebeck coefficient of the J-type thermocouple is 50 microvolts per Kelvin or Celsius. When 100 degrees temperature difference is applied, one thermocouple will produce 0.005 volts, which is very low. But we cannot increase the temperature because it is impractical. Now let us increase the number of thermocouples. When thermocouples are connected in series, they become a thermopile. Here I have made a thermopile consisting of 25 thermocouples. So according to the calculation, it must produce 0.125 volts. Now let us test this thermopile. With the same setup, I have kept the thermopile in the hot water and the cold water. Now I will connect the positive pin to the positive terminal and the negative pin to the negative terminal. So as you can see here, 0.15 volts is produced. So that is approximately what we have calculated. The Seebeck generator is a type of thermoelectric generator. It produces electricity directly from heat, leaving no emissions behind. Even the waste heat can be converted to electricity, thus making the electricity production more efficient and boosting the economy. Dhanyawad.